Hello dear students, I am Professor Mandar Dikshit from Electrical Engineering Department. Today we will solve one more problem on Norton's theorem. The problem which I have taken is, by Norton's theorem find the current in 4 ohm resistance in the following circuit. So this is the circuit and this is 4 ohm resistance. We have to calculate current through this 4 ohm resistance using Norton's theorem. Let us start the procedure. The first step to solve the problem will be, we have to remove the resistance 4 ohm from the circuit. The first step is remove RL, which is equal to 4 ohm, through which current has to be calculated from the circuit. Mark the two terminals as AB and short circuit them according to Norton's theorem. Then our circuit will be as it is. Then our circuit will be these are our terminals AB where 4 ohm resistance was previously connected, and we have short circuited these terminals, and current IN will be calculated passing through this short circuited AB. So second step will be, we have to calculate IN, which is Norton's current. For calculation of IN, current, which is current through AB, we will simplify the circuit. We will convert with the help of source transformation the parallel combination of 6 ampere current source and 2 ohm resistor into equivalent series combination of voltage source and resistance. So our circuit will be modified after conversion of this current source into voltage source. So this 6 ampere current source and 2 ohm parallel resistance will be converted into a series voltage source and a series resistor. The value of voltage source is 6 into 2, 12 volt, and 2 ohm will be connected in series as it is as per source transformation technique. Now we will use mesh analysis to solve the problem. So mark unknown currents, mesh currents in the circuit. So this is mesh 1, which is marked as I1 as unknown current. This is mesh 2, which is marked as I2 mesh current, and the remaining mesh 3 as marked with I3 unknown mesh current. Apply KVL to first mesh. Now for mesh 1, we are moving in mesh like this is our mesh direction. Current direction is also same. So for 2 ohm, the voltage drop will be minus 2 I1 because current direction and loop direction are same. When we come across 10 ohm resistor, 10 ohm resistor is common for first mesh and second mesh. Hence current flowing through 10 ohm resistor will be difference between I1 and I2 or resultant current I1 and I2. Now we are in loop 1, so we will take I1 as higher than I2. Hence for 10 ohm resistor, the voltage drop will be minus 10 I1 minus I2. Then we'll come for 1 ohm resistor. This 1 ohm resistor is common for mesh 1 and mesh 3. Hence current flowing through 1 ohm resistor will be resultant of I1 and I3. Again we are in loop 1 or mesh 1, hence we will take I1 as higher. So for 1 ohm branch it will be minus I1 minus I3. As loop direction and current direction are same, so voltage drop will be negative everywhere. Then remaining is the voltage source. First terminal is negative, second terminal is positive when I move in mesh. So voltage drop will be plus 12 volt. So combine all these values and put in the mesh equation applying KVL. Minus 2 I1 minus 10 I1 minus I2 minus 1 I1 minus I3 plus 12 is equal to 0. By simplifying the terms, we will get first equation as minus 13 I1 plus 10 I2 plus I3 is equal to minus 12, which is our equation 1 for mesh 1. Similarly, we will apply for mesh 2. For mesh 2, as we move in mesh 2, the first element is 10 volt source. When I move in mesh 2, the first terminal arrives as plus or positive and second will be negative. So it will be drop in voltage. Hence 10 volt will be written as minus 10 volt. Then when I go from mesh in 2 ohm resistor, it will have only single current, so it will be written as minus 2 I2. This minus sign is because of mesh direction and current direction are same, hence voltage drop will be taken as negative as per KVL sign convention. Then we will come across 3 ohm resistor. This 3 ohm resistor is common for loop 2 and loop 3. Hence, the current flowing through 3 ohm resistor will be resultant of these two currents. As we are in loop 2, so we will assume I2 to be higher than I3. So for 3 ohm resistor, the voltage drop will be minus I2 minus I3. Again minus sign is for same direction of loop or mesh and current. Then we will come across 10 ohm resistor. Here again 10 ohm resistance current will be difference of I1 and I2. Previously we were in loop 1, now we are in loop 2 or mesh 2. So I2 will be taken as higher than I1 in this case as we are following mesh 2. So for 10 ohm resistance, the current voltage drop change will be minus 10 I2 minus I1. So we have completed mesh 2. Let us write down the all terms. Minus 10 volt, minus 2 I2, minus 3 I2 minus I3 and minus 10 I2 minus I1 is equal to 0. Simplify the equations, we will get So we got equation 2 for mesh 2, 10I1 minus 15I2 plus 3I3 is equal to 10. Finally, we will apply KVL to mesh 3. For mesh 3, we will start through 1 ohm resistor. 1 ohm resistor is common for mesh 1 and mesh 3. So current flowing through 1 ohm resistor will be resultant of I1 and I3. Now we are in mesh 3. So we will assume I3 to be greater than I1. So for 1 ohm resistor, the voltage drop will be minus I3 minus I1. Then we'll move to 3 ohm resistor. Again 3 ohm resistor is common for second mesh and third mesh. So the current flowing through 3 ohm resistance will be resultant of I3 and I2. Previously we were in loop 2, so we have taken I2 minus I3. Now we are in loop 3. So the equation of voltage drop across 3 ohm resistor will be minus 3. It will change now to I3 minus I2 as we are in mesh 3. So we will assume I3 to be greater than I2. Then this is our IN. Then we have a source. As moving through mesh, the first terminal which gets is negative and second terminal is positive. So that is increase in voltage or rise in potential. So according to KVL, we have to write it as plus 24 volt is equal to 0. By simplifying the equation, we will get final equation as equation number 3 for mesh 3 as I1 plus 3I2 minus 4I3 is equal to minus 24. That is equation number 3. By solving these 3 equations of mesh 1, 2 and 3, we will get values of I1, I2, I3. As we are interested to calculate current through AB, and current through AB, short circuited AB is I3. So we will finally calculate I3 from the equation and we get I3 as 12.39 ohm. Hence our IN is 12.39 ampere. Next step will be calculation of RN. For calculation of RN, we have already removed the load resistance RL, which was equal to 4 ohm, and we have to replace voltage sources by short circuit and current sources by open circuit. So from the diagram, we will remove current source as open circuit and voltage source will be replaced by short circuit. Then we will get following circuit. Here there was a current voltage source, we have replaced that voltage source by short circuit. Here there was a voltage source of 10 volt, we have replaced it by short circuit. Here it was a supply or voltage source of 24 volt, we have replaced by short circuit. These are AB terminals of load resistance. We have opened it to calculate RTH. And only resistances are in the circuit. By here observing here, we will calculate RN. Let us mark the other nodes. C, D, E and F. If you observe in the circuit, C, D and E forms a star connection, which we can convert into equivalent delta connection. Let us draw this equivalent converted diagram and our circuit will change accordingly. This is our delta converted from this star. Let R1, R2, R3 be the values of converted delta circuit. From star to delta conversion expression, we can write the values. R1 will be, for delta conversion technique, the equivalent delta resistance will be addition of the resistances formed in star. So for R1 is formed between 1 ohm and 10 ohm, hence 1 plus 10. R1 is formed because of two star resistances 1 and 10. So addition of these two resistance plus multiplication of these two resistance as third term divided by the remaining resistance. For R1 remaining resistance is 3 ohm. So 1 plus 10 plus 10 into 1 divided by 3. From this we will get R1 as 14.33 ohm. Similarly, we can write down for R2. For R2, the two resistances are 10 ohm and 3 ohm. Hence, 3 plus 10 plus 3 into 10 and remaining resistance for R2 is 1 ohm. So, from that we will get R2 as 43 ohm. For R3, the two resistances are 1 and 3 of star connection. Hence, we have written 1 plus 3 plus 1 into 3 divided by remaining resistance. For R3, remaining resistance is 10 ohm. So, 10 ohm. Then we will get R3 as 4.3 ohm. So, we get values of R1, R2, R3 which are star converted value into delta. Substitute all the values of this delta into the circuit. So we have substituted values of R1, R2, R3 which is delta connected resistor. If you observe the circuit, 2 ohm resistor and 14.33 ohm resistor are forming a parallel connection. Similarly, 43 ohm resistor and 2 ohm resistor are forming parallel connection because they are connected between same points, that is D and E. So this can be converted into single resistance by parallel combination. Then our circuit again modifies. So this resistor is parallel combination of this resistor. So if you take parallel combination of 2 ohm and 40.33 ohm, I'll get the value as 1.755 ohm, and if you take parallel combination of 43 and 2 ohm, I'll get value as 1.91 ohm. Again, if you observe, the D point forms a series path, hence 1.755 ohm and 1.91 ohm resistance are in series connection. Then they can be added in the circuit. So further our circuit will modify. Addition of 1.775 and 1.91 will be the resistance. The value will be 3.67 ohm. Now these two resistances, again 3.67 ohm and 4.3 ohm are parallel and they are connected across AB. So finally we will write down RAB as RN. So if you solve the parallel circuit for 3.67 and 4.3, we will get Rn as 1.98 ohm. So we have calculated value of In and Rn. The next step or last step will be calculation of IL by drawing Norton's equivalent circuit. We will draw Norton's equivalent circuit. So this is our Norton's circuit with Rn as 1.98 ohm and In as 12.39 ohm ampere. So we will reconnect RL in the circuit. The value of RL is 4 ohm. The current flowing through RL will be IL. The IL will be calculated using current division rule as substitute the values of In, Rn and RL. Finally, I will get IL as this is our answer. Current flowing through 4 ohm resistor, which is IL, equal to 4.1 ampere, which we have calculated using Norton's theorem. Thank you for watching this video.